Okay, now we will continue with diverging lens. If our object is very far, we talked about the focal point. We said that the rays will emerge outward, away from each other. They will not bend inward as with converging lens. So, what do you expect, girls? These rays, are they going to meet anywhere here? So for sure no. Even if we extend them, they are not going to meet anywhere here. So we can't get a real image with diverging lens. So it's impossible to get a real image using diverging lens, because the real path of light won't meet together, the real rays. Okay, so these rays, they diverge away from each other as what? As if they were coming from a principal point here. So that's why this point, what do we call it? We call it principal focus. So for diverging lens, the focal point is defined as the point from which the diverged rays appear to originate. So these rays, they appear to have originated from where? From this point. So therefore, this is the principal focus. So pay attention, girls. The principal focus for diverging lens is here, is on the same side of our object, okay? But for converging lens, where was it? It was here, okay? The principal focus, because the rays, the parallel rays, they pass through the lens and they meet at the focal point here, okay? So for diverging lens, the principal focus is on the same side of the location of the object, okay? Now I will show you this visual concept about drawing the rays in order to get the image.
A diverging lens can produce only one kind of image, a virtual image. To locate the image, start with a ray parallel to the principal axis. Since we know this is a diverging lens, it is easy to remember that this ray is bent outwards as though it originated at the focal point on the left. Draw a second ray that passes straight through the center of the lens. The image appears where the two rays appear to have originated.
Okay. Now we will continue. So girls, we have here also 3 standard rays. Pay attention with me. The first ray, all the rays first are coming from where? From the tip of our object. Okay, the first ray is coming parallel to the principal axis. How will it diverge? How will it bend? It will bend away from the principal focus. Why? Because we learned that from the first case we said all the rays that are coming parallel, they will bend away as if they were coming from the principal focus. So we learned from the first case that any ray that is parallel to the principal axis, it will leave the lens as if it's like coming from this point, from focal point. Okay, what about the second ray? So this is the first ray. What about the second? You remember for converging lens, we said the second ray is just the opposite of the first. Okay, so let's revise it first in our mind. What is the opposite of the first? The opposite is, girls, the ray, if it's like going toward F, okay, how does it bend? It bends parallel. Okay, so this is the second ray. It's going toward F, but the other F, where is it now? It's here, in the back of the lens. So we draw it as if it were going toward this focal point. So we draw it as if it were going to this focal point. And as it leaves the lens, how does it leave the lens? It leaves the lens parallel to the principal axis. So it is just the opposite of the first one. Okay? So first one parallel, it leaves the lens away from F. Second one, it's directed toward F and it leaves the lens parallel to the principal axis. The third one, it is the easiest one. So when, for example, you forget how to draw the second, you can just draw the third, because only with 2 rays we can find the intersection point, but usually we draw the third in order to make sure of our intersection point. So the third one, we said any ray that goes through the center, optical center, it continues without any refraction. Okay, it continues in a straight line. So this is the third ray. Here, this 1, 2, 3. If you extend them, will they meet anywhere here? So no. So what do? We trace them backward. What do we trace? We trace the emergent rays, the refracted rays, these rays that leave the lens. Pay attention. So we trace these rays backward. They meet where? Here. So they meet at a point here, and then we continue our image. What can you notice about the image created? The image created, it's smaller, and this is what we said at the beginning. Diverging lens, it's always used to produce virtual images that are smaller than the object. Okay, so the image is smaller, it's erect. What means erect? It means it's upright, it's not upside down. What also? It's virtual. Why it's virtual? Because it's made by the intersection of the apparent path of light, not the actual path of light. Okay, and where is it placed? It's placed always somewhere between the focal point and the lens. Okay, so for diverging lens, we don't have many cases, we just have 2 cases. Pay attention with me. What are these 2 cases? So these 2 cases are this one. This is the first case, when the object is very, very far. The image created is at the focal point. Why? Because the parallel rays coming from the object, they diverge as if they were coming from this focal point. So when we trace the emergent rays backward, they meet at this point. So the image is produced is here, it's diminished, it's smaller, it's reduced, it's like a point size. It is virtual, and it's placed for sure in the same size, on the same side, sorry, where our object is. This is the first case, when the object is very far, at infinity. Second case, when the object is placed anywhere between here, anywhere beyond or behind the optical center. So in this case, the rays will diverge, and we will trace them backward, and we will find the intersection point, and the image will be placed inside the focal length. So where is the focal length? Here is here, on the same side of the object. Okay, so the characteristics of the image produced by diverging lens are very clear. Always virtual, always smaller, always produced on the same side of the object, and it's always for sure upright because it's virtual. Okay, so you have a video, I will upload it later. These are the characteristics regardless of where the object is placed.